Okay, Chapter 8, Day 7. What we're going to focus on today is how do we solve equations that contain logs in them? So we have an equation now that has logs in them. How do we solve them? So there's two cases. The first case is if we have logs on one side of the equation. So let's take a look at that first. So here we are. We have a problem in which log is located on one side of the equation. Well, the first thing we're going to do is condense the log side if possible. So if it was written out more than just this, we would want to condense it in so it looks like just log written once. All right? Don't need to do that here. We'll see that in the next problem. Next, rewrite into exponential form. Well, that's what we did on day 1, where we dropped the word log and trade the exponent in the answer. So rewrite into exponential form. So the word log is going to go away. The 4 is still our base. And the 2 and the x plus 3 trade places. We've done that a lot of times. Notice now I don't have the word log. Solve for x. Just whatever's left, solve for x. And 4 squared is 16. Take away 3. X is 13. The last thing you really need to do here, the last step, I'll put in as step 4, is you need to check. Now, when we check, we're checking to make sure that this number doesn't give us an undefined situation. If you remember earlier in this unit, we said that this number here can never be 0 or negative. So we want to make sure that when we put this number in, we get an answer that is at least 0. Not at least, more than 0 actually, because if it's 0, we're still in an undefined situation. So check to make sure the answer doesn't give an undefined, and I'll just put undefined situation. And again, what do I mean by that? I mean that we have to make sure that what we're taking the log of is greater than 0. And 13 plus 3 is definitely a number greater than 0, so we're okay. All right, let's take a look at another example then. Notice, in this one, logs are on one side, but they're expanded out. We have to condense them back in. So step 1, condense the log side if possible. That's our whole re-expression properties. Well, I know that plus came from multiplication. So I'm going to rewrite this as the log of 12x times 2. Because plus turned back into multiplication. The base that I don't see is 10. I'll write that in. Okay? So then I have the log of base 10. 12 times 2 is 24x. All right, so step 1, done. Step 2, get rid of the word log and trade these two things. So 10 to the 3rd power is 24x. Step 3, solve for x. So 10 to the 3rd, that's 1,000. So x is going to be 1,000 divided by 24. Check to make sure it doesn't give us an undefined situation. Well, if I put 1,000 over 24 times 12, is that going to be negative or 0? No, so that's okay. And I'm not putting it here at all, so I don't have to worry about it. So it's a good answer. We'll take it. Take a look at the next problem. All right. In this problem, log is written one time, so it's already been condensed. So let's go through and follow the process. Well, I'd like to divide by 2 first to isolate the log. So I'm going to divide by 2. And I have log base 3 of x minus 1 equals 1. Now, I can drop the word log, and I get 3 to the first power is x minus 1. Okay? And 3 to the first power is 3. Add 1. 3 plus 1 is 4. So, let's check. 4 minus 1 is 3. It doesn't give me an undefined situation. And I'm okay. Take a look at now what happens if x is on, or logs is on both sides. So notice now, logs appear on both sides of the problem. So I have to condense both sides where possible. This doesn't need any condensing. This does, so I better condense it first. So this just comes along for the ride. 3 log base 7 of x plus turns back to multiplication. So log base 7, 4 times 2. And on this side, you might have noticed that, wait a minute, Mr. Pat, isn't this 3 out front? Can I really put it as a power? And you need to, because right now, if I divide by 3, it just gives me a mess. So our power rule would say I can rewrite this as log base 7 of x to the third. Okay? So I have used my power properties for both of these sides. I got it now down to just log equals log. Well, if log base 7 of x cubed is log base 7 of 8, that's only true if x cubed equals 8. So once you have it down to here, you take out the log on both sides. Just take it out. All right? So x cubed equals 8. It's the same base. If they weren't the same base, you couldn't do that. And now solve what's left for x. Step 3, just solve what's left for x. I'll undo a cube by taking the cube root or raising each side to the 1/3 power. So x equals 8 to the 1/3, which is the cube root of 8, which we know then is 2. Step 4, again, check your answer. So I take the 2 and put it into the beginning. If I put a 2 here, that's positive, I'm okay. And that's the only place I'm putting it, so it's a good answer. Circle it. So again, to recap, if logs are on one side, condense if possible. Take out the log, trade exponent and answer, solve what's left, check it. Okay? If logs are on both sides, work with condensing both sides down to log something equals log something, and then you can just drop the word log, and what you have left, solve for x. Check it. Every year in the Regents exam, if they give a word problem like this, or a problem that is extensive, a lot of times if you get 2 answers, 1 answer, and when you check it, it might not work out. Okay? And that's it.